Alright guys, so now we are going to talk about the sections 1.4 using the definitions of the trigonometric functions. At the end of the day, you should be able to use the identities below to compute quantitative relationship between the trig functions. So you have the 6 trigonometric functions that we've seen in the section 1.3. And you have also to be able to use the reciprocal identities. Okay? So let's try to work out the first problem. All right? So, when I look at sinus theta, it's equal to 1 over cosec theta. Sinus theta equal y divided by r, and cosec theta equal r divided by y. Therefore, I end up to have at the end of the day y over r equal y over r because I flip my second fraction. So when I flip r over y, it becomes y over r. Okay? So that is okay. Now, let's try to look at cosinus theta equal 1 over sec theta. Well, x over r equal 1 over r divided by x. I flip my second fraction. Therefore, x over r equal x over r. Great. This is exactly what we are looking for. Now, if I'm looking at tangent of the angle theta, which is equal to 1 over cotangent theta. Tangent, it's y divided by x, 1 over x divided by y, and I end up to have x over y, y over x equal y over x. The last thing I want to say is this. If sinus theta equal 1 over cosec theta, therefore cosec theta, 1 over sinus theta equal cosec theta. If 1 over cosinus theta will be equal to sec theta, and for this one, 1 over tangent theta will be equal to cotangent theta. Okay? Alright, so now let's move on to number 2. Find tangent theta given cotangent theta. Well, now it's pretty easy because if I know that tangent theta equal 1 over cotangent theta, that means tangent theta will be equal to 1 over 4, and therefore the answer is 1 over 4. Find sec theta. Well, I know that sec theta equal 1 over cosinus theta, so sec theta will be equal to 1 over negative 2 square root of 20 divided by square root of 20, which is going to be negative square root of 20 divided by 2 because I flip my fraction. And if I simplify, I end up to have a 2 square root of 5 negative 2 square root of 5 divided by 2. The 2 divide out, and the answer is going to be negative square root of 5. Find sinus theta. Well, same idea. 1 over sinus theta. Sinus theta equal 1 over cosec theta, which is 1 over 12 divided by 5, and then the answer at the end of the day is 5 over 12. Now, let's work on finding sine and range on the trigonometric functions. Alright guys, so now let's talk about the sine of the trigonometric function for angle in valuation quadrant. And remember that we are reading the value of your cosinus. We are reading the value of the cosinus on the horizontal axis with a value between 1 and negative 1. And we are reading the value of the sinus with a value between 1 and negative 1 on the vertical axis. Okay? So if I define the quadrant 1, the quadrant 2, the quadrant 3 right here, and the quadrant 4 right there, I can see right here that the sinus is positive, and I'm going to right, like this. The sinus is positive. Right there, the sinus is negative. On this side, the cosinus, I'm going to use the red one. The cosinus is negative, and right here, the cosinus is positive. Okay? So, if I go back to this graph right here, I can define the quadrant 1 with a cosinus positive and a cosinus of an angle, so a cosinus theta positive. Right there, the cosinus will still positive in a quadrant 2. In a quadrant 3 and quadrant 4, now right here the cosinus is negative. I don't know what happened. Right there, the cosinus is negative. And right here, the cosinus is positive. When I look at the sinus of my angle is positive, the sinus of my angle is positive, the sinus of my angle is negative, the sinus of my angle is negative. Okay? Pretty easy because we're having 0, 0, 0 on the x-axis, and so I can easily remember that on this horizontal axis, this is where I'm reading the cosinus, and on a vertical axis, this is where I'm reading my sinus. So now to state the sine of the sixth trigonometric function, when I am at theta equal 97 degree, which is greater than 90 degree, that implies that I am in a quadrant 2, and in my quadrant 2, I'm supposed to find the sinus of my angle theta, or I'm going to put 97. 97 is going to be positive. The cosinus of 97 degree will be negative. The tangent, as it is supposed to be the sinus over cosinus, is going to be negative. The sec and the of 97 degree will be negative because it's a 1 over cosinus, and cosinus is negative. The cosec of 97 degree will be positive, and the cotangent will be negative. If I look at the angle theta equal 260 degree, 260 degree, it is less than 270 degree, and therefore we are in the quadrant 3. That implies that my sinus of 260 degree will be negative. The cosinus will be 260 degree will be also negative. I'll let you finish and tell me what is it about the tangent, cotangent, or 260 degree. What is it? Please tell me. The cosec of 260, tell me what it is, and the sec of 260, tell me what it is. Okay? Now, number 8. On the number 8, I must just remember that if I go to a negative, I'm going in that direction, and obviously this will look like a negative 80 degree. Therefore, I end up to be in a quadrant 4, and so it's pretty easy for me to now define the sine of the sixth trigonometric value. All right, so I'll let you finish the problem number 9 and 10. Very easy to define. Now let's jump on the range of 6 trigonometric function. Draw 8 angles below the 4 quadrant angles and 4 angles in between, and note the relationship between the value r, x, and y. Okay, so let me do that with you. All right, guys, so I did for you this practice. I'm going to ask you to fill that up, and if you have any question, just let me know. Okay, so now let's go to practice and state whether it's possible or not for cosine theta equal -1. No. Number 12, it's no, because the value of cosine theta has to be between -1 and 1. The second one, state whether it's possible for cotangent equal -121. Yes, it is possible. Why? Because the range is all real numbers. Number 14, it's not possible. No, it's not possible, because sec theta has to be greater than 1, or sec theta has to be less or equal than -1. In this problem number 15, suppose that theta is in quadrant 3 and tangent theta equal 5/9. Find the value of the remaining 5 trigonometric function. So first of all, tangent theta equal y divided by x first. And I know that they are telling me it's equal 5/9. So therefore, I can define that x will be equal to 5 and y will be equal to, y will be equal to 5 and x will be equal to 9. But I need to remember that they are telling me that theta is in quadrant number 3. What does that mean? That means in my quadrant number 3, the value of sinus theta is negative and the value of cosinus theta is negative. That implies that the tangent theta has to be positive because it's sinus divided by cosinus. So I must also think about, hey, instead to be 5 and 9, it could be -5 or -9. And therefore, I could have y equal -5 and x equal -9. Now, if I calculate the value of r, okay, let's calculate the value of r. And if I calculate the value of r, I end up to have the square root, -9 square plus -5 square, and end up to have r equal the square root of 106. Now I know the value of r, I know the value of x, and I know the value of y. I know that sinus has to be negative and cosinus has to be negative. So I can easily say that cosinus of the angle theta, which is x over r, it's going to be -9 divided by square root of 106. The sinus of the angle, I know it has to be negative, so it's going to be, I don't want that, so let's do this. It's going to be -5 over square root of 106. The tangent has to be positive, therefore it could be equal to 5/9, and they are telling me it's 5/9. And I'll let you find the other one, which is the sec, the cosec, and the cotangent. Very easy. All right, problem number 16. I'm going to let you do this problem number 16 by yourself. And we will go about the Pythagorean identities on another video. Unfortunately, I can't do it in 15 minutes. So I will have to use 5 more minutes for just a video for this, for the rest of this lecture note section 1.4. Thank you very much.